Hello makers, this is Joel with MakerStudio, and today I'm going to be working with the BBC Microbit. Now I know that there are some teachers who consider themselves makers or are at least interested in incorporating maker kinds of projects into their classroom. But I also know from talking to teachers that one of the things that scares teachers about incorporating things like this is they just are a little bit fearful, or they feel like they don't know enough to incorporate certain things. So one of our goals here with this MakerStudio project is to help you feel a little bit more comfortable and hopefully a lot more confident about incorporating some of these into your making and maybe even into your classroom as well. So we're going to start with this one, which I know people get fearful about coding and incorporating code into classrooms and into making because they feel like they don't have enough training to get to where they want to be. So we're going to start with the BBC Microbit, which is, in my opinion, is one of the best introductions that you can get to physical computing. Let's stop right there. What's physical computing? Physical computing is when you take the little bits of code that you create and then you connect them to the outside world. So you make a light come on, or you check the temperature of the water, or whatever it might be. It's not just code that lives on your computer, it's code that lives out there in the world and is connected to the world. I have used the BBC Microbit with students down to probably 3rd grade. And I will tell you, we do a family make night where parents and their children come in and we do projects together. Usually the students feel way more comfortable with the BBC Microbit than their parents do. The parents are like, it's code, I don't want to touch it. And the kids are like, let's dig in, let's start pressing keys and see what happens. So yeah, down to the 3rd grade, I think that's totally doable. And then I use them on up through the high school where I spend most of my time. So you can do all kinds of really, really cool things with these. And here's what it looks like. It's just a really small little rectangular board. On the front, you have this LED 5x5 LED matrix. You've got 2 little push buttons, and then on the back, that's where this thing really comes to life, because you've got all kinds of sensors that are just packed onto this little tiny board. So it's not like a Raspberry Pi where you have to go and buy separate sensors to attach to this, although you can attach all kinds of things to this. This one comes pre-packed with a whole bunch of stuff on there already. So it has an accelerometer, so a really popular project to do with these is to create like a pedometer, put it on your wrist and count your steps. It has a compass, so it can tell you which way you're going. Let's see, what else? It has a Bluetooth antenna, so you can have 2 microbits talking back and forth to one another. There's a little reset button on the back. And I feel like I'm missing something. There's a temperature sensor as well, so you can do temperature sensing as well. I've done projects where creating interventions for, like, say, a natural disaster or something that would be a climate change related kind of project that you can do with these. So you can incorporate them into all kinds of curriculum. It doesn't have to just be computer science, although they can fit really well into the computer science curriculum as well. This down here along the bottom, you have a ground, you have the access to 3 volts, and then the rest of these are GPIOs, which stands for General Purpose Input and Output. This is where you can attach other things to the microbit. So today what we're going to be doing with the microbit is we're going to be coding a rock, paper, scissors game. So the way that this is going to work is we're going to write some code, and then it's going to live on this little board, and when we shake it, it's going to choose either a rock or paper or scissors. Now, if you want to get into a more advanced level of this, again, you have that Bluetooth function. You could have two of these playing back and forth and counting who wins how many hands and that sort of thing. We're going to keep it really simple today so that you can have one simple project that you can be off and running with in no time at all. Okay, so let's get started. What you are going to need when you open your box is you've got a battery pack, which is going to connect to the Microbit. You need a USB cable, and that's it. That's it. That's all that you need to get started. Now, as far as the code environment goes, online, everything lives online. So another reason that I love the Microbit is that my students don't have to create an account. They're not required to sign up for anything. They're not going to receive emails or solicitations or anything else. There's no privacy concerns at all. It's all out there on the cloud. Once you've written your code, you just download it, plug it into your computer, plug it into the Microbit, and you're off and running. Your code is there. Okay, so let's jump in. And I'm going to assume for folks who are watching this that you are starting at, let's say, level 0, maybe level 1. So that's where we're going to proceed. So if you're a master computer coder, you're probably going to get a little bit bored. It might be a little bit slow for you, but that's what we're going to do. All right, so you're going to go to microbit.org. And then once you're on microbit.org, you're going to find the little orange button that says, Let's Code. You're going to click on that. That is going to bring you into the code environment that you're going to use. Here's the thing that I love, another thing that I love about the Microbit. You can choose to do block coding, so if your students have already done Scratch, or if you've done Scratch and you're familiar with that, that's going to feel very, very familiar to you. You can then switch from blocks into JavaScript. So this is kind of a good entryway for students who are making a transition from doing block coding and things like Scratch and then moving into more language-based coding of JavaScript. And there's even a Python editor that you can use for the Microbit as well. So Python, again, if you're kind of stair-stepping your abilities here, Python is a great introduction into Raspberry Pi because you can write lots of code and make it run on a Raspberry Pi. So if you're kind of trying to ramp people up, it's a good transition from block to language, and then it's a good transition from this little board that can do a whole lot into more higher skill development boards and computing with things like the Raspberry Pi. Okay? All right, so let's get familiar with the code environment. Over on the left-hand side of your code environment, you have a picture of a little Microbit. That is your emulator. So any of the code that you write over in the code section will live on that emulator, so you can check your code before you download it and commit it to your Microbit. Throughout the middle there is this long thin band, and those are your code blocks that you're going to be using. They're separated, they're all color coded, so you go basic, input, music, LED, and so on. That's where you'll search for all of the bits of code that you'll drag over to the right, and to the right is where you will actually build your code. Okay, so the rest of the environment around that major central section, you can go home, you can share your code, so you can say, hey, I want to send this to my friend. You can send it to your friend, and then they could modify your code, add things to it, and then send it back to you. So you can share code between you. Down at the bottom is how you download and you name your code. So once you've completed your code, you'll just download it right there, send it over to your Microbit. Okay, let's get coding. So the first thing that we need, I said we're gonna build a shake, rock, paper, scissors. So the first thing that we're gonna talk about is the input. So the input for this bit is going to be shake, on shake. So if you go into your input block in the center there, you will see all the different inputs that you can have on button A pressed, on button B pressed, on pin P0 pressed, etc. We want to grab on shake and we want to drag it over into our code area first. So now we're good. You will also see that at the top you'll have two bits of code that say on start and forever. for right now, you can just forget about those. You can even delete them if you want to, because we're not really going to be using those. We're just going to be using the input of the shake, okay? So the next thing that we're going to do is we're going to create a variable. Now variables, those are one thing that I always take a little bit of a pause to talk about with students, because students who have gone through algebra and they know to solve for x and things like that, they're familiar with that concept of a variable. But for some younger kids, that doesn't quite make sense to them. So here's where I take a pause to say a variable is one thing that will stand in for another thing, right? So we are going to create a variable that we will call weapon. Okay, so the next thing that we're going to do is we're going to go into the variables and we're going to say make a variable and we're going to call it weapon. Now, if weapon is too weapony for you, then you can just call it like item or something else. So do that, create your variable, and then you will see that populates in that list weapon, set weapon to, and change weapon. Okay. Really, for right now, the only thing that we need is that sort of long triangular one that says weapon. Just like there's color coding, everything is also shaped to fit together. So if you look for the clues in the code, it will tell you it's looking for this long, sort of oblong circular shape. All right, so now we've got our weapon set. We're going to say set weapon to. All right, we're going to drag that one out. Set weapon to 0 is what it's going to say automatically. But we're going to change that, because here's what we want to do. We want 3 different options, right? We want rock, we want paper, and we want scissors. So what we have to do is now we have to use a little bit of math, and you got to think like a computer, because a computer counts 0 as the number, right? So you're going to say, you're going to pick a random number between 0 and 2, and that gives us 3 options, 0, 1, and 2. Okay, so we're going to go into our math. We're going to find the pick random 0 to 10 block, and we're going to drag that over, and we're going to replace the 0 that was in that set weapon to block with the pick random, and we're going to make that 0 to 2. So now we have it. When we shake it, it's going to pick a number 0, 1, or 2. Okay? Now, this is where things get fun, because now we start to use some logic, because we want to say, once I shake that, if you pick this number, then do this. Okay? So we're going to go into logic, and we're going to find an if statement. So the if statement that you're going to see is if true then. Drag that out into your code, and now you've got if true then. Notice that you've got this long shape with the pointy ends there, okay? So now we're going to change that little long bit to another piece of logic that says 0 equals 0. So switch that to 0 equals 0. If 0 equals 0, now we're going to get rid of that first 0, and we're going to drag in our variable of our weapon. We're going to say, so now what our code says is on shake, set the weapon to pick a random number between 0 and 2, and if that random number, if that weapon is 0, then we're going to do something. What's the thing that we're going to do? We're going to make that one paper. So what we're going to do is we're going to have the LED matrix here on the front show us a piece of paper. A representation of a piece of paper, okay? So we'll go into the basic where it says show LEDs. We'll drag that in, click it into that if statement. So now it will say if weapon equals 0, then show these LEDs, and we'll array them around the LED matrix. All right, great. You're off and running now. At this point, this is where computing, writing code gets easier, right? Because now you can just duplicate things that you've already done and have them repeat in here. So the next thing that you're going to do is down at the bottom, there's a little plus sign. Down on the bottom of your logic statement, that sort of teal green one. It's about the color of my shirt. If you click that plus button, click it 2 times, now you're going to get else if and then else. So now your logic statement should read if weapon equals 0, and then your LEDs, and then else if, and then else. okay? So let's worry about the else if statement next, okay? Because now what we're gonna do is we're gonna say, if the weapon is 0, show paper, else if the weapon equals 1, then we're gonna show, let's say, rock, okay? So now, do exactly what you did there with the weapon equals 0 at the top, and replace that bit in the else if to else if weapon equals 1. Now grab your show LEDs, drag it in there, and we're gonna create a rock. The way that we're gonna do that is we're gonna take the central 9 bits in the inside of here, and we're gonna light those up, okay? And then in the else, we don't have to add any other logic because it's the only option left. We've already accounted for if we pick 0 or if we pick 1. Now all we have to do is show the last of those 3 options. So all you have to do now is just bring in show LEDs and make your scissors, and this is how I made my scissors. You can make them however you like. Okay, that's it. Your code is done. Okay, so back to it. One thing I failed to mention before, this is a micro USB, so that's what you're gonna need with this. If you still have the one that came in the box, that's great. It's gonna work perfectly. If you're using a random that's laying around your house like me, make sure that it is capable of sending and receiving and is not just a charging cable, okay? So I've loaded my code onto here. Now the only thing I have left to do is I can just plug this in, and we're gonna see if it actually works. So let's give that a shot. There we go. We got paper. Let's roll it again. We got scissors, and we got a rock. So we got all 3 of them showing up onto the Microbit. And one last thing that I want to talk about here with these, and this is what I was talking about earlier. So we were talking about physical computing of attaching things, making code work live in the real world, right? So one of the really cool things about this is you can attach, if you have just these little alligator clips, or you can find other ways to do this. If you want a more permanent solution, I guess you could even solder them in, but why would you want to do that? But anyway, that's another story. So now what you can do is you can plug things up and you can make lights turn on. You won't believe how excited people can get when they just turn an LED light on through a piece of code. Now, I just connected to the 3 volts and to the ground and turned the thing on, but you could also write into your code, hey, anytime I press the A button, or anytime I shake, or anytime I win, turn the light on. Or anytime the temperature becomes higher than 30 degrees Celsius, turn the light on as a warning or something like that. So you can attach the code and make real things happen in the world, which is fantastic. The other great thing about this is there are tons of manufacturers out there who are building things specifically for the Microbit. There's tons of little add-ons that you can find, things that will incorporate push buttons. One that I saw this morning, that was a drone that is used to control. The Microbit is the brain of the drone. So people are adding all kinds of really, really cool things that you can do with the Microbit. Sometimes I refer to the Microbit and the Arduino and other little programmable boards as a dumb machine. Partly that's just a way for me to say, ha ha ha, the robots aren't going to take over, I'm going to live on and I can control this technology. And then the other part is there's a little bit of truth to that, because why I call it a dumb board is it's only going to run one program. Once you plug your battery, this thing is going to run that bit of code until it turns to dust, or the batteries run out, or you step on it, or whatever. That's all that it's going to do. Whereas more advanced, like Raspberry Pi and things like that, that's a fully functioning computer. So it can do more than one thing. So it can attach to a sensor, but then that sensor could be out on the internet and it could be collecting data from something else. So it can do multiple things and be used in multiple ways. An Arduino and a Microbit and other programmable boards, and there's 9 million different varieties of them, they're a little bit dumber than that. They're just gonna run that one bit of program until they stop. So if I plug this in, if I write myself a new bit of code, plug it in and download it, that old rock, paper, scissors game is gone. And it's replaced with whatever the new code is that I've put on here. So that's it. That's all I've got for you on the BBC Microbit. Hopefully this helps you to get a little bit more confident, a little bit more comfortable, to incorporate a little bit of physical computing into your classroom or even just into your own personal making. Till next time, this is MakerStudios. See you later.